This is a review lesson on slope and rate of change, so you should have some background on slope and rate of change. In complete sentences, I want you guys to do now, which is explain how to find the slope of this line, both graphically and algebraically, and then find the slope of that line, both graphically and algebraically. You should have the same slope, both graphically and algebraically. So I want you guys to take 3 to 5 minutes, do that, take your time, pause the video if you haven't, and play it again once you are done. So slope is always between how many points? We always need 2 points for slope. So this nice graph actually labels 2 points for us. So the first thing we want to do when we're trying to find slope graphically is we want to find 2 points. So you must first find 2 points on the line whose coordinates you know. And I know it's labeled for us right now, but you want to have points on the line, if it wasn't labeled, where it intersects the X and the Y graphing lines. So like right here would be a good line, a good point. Right here would be a good point. Right here would be a good point. All those points would be great points. So our next step, after we find 2 points on a line, we're going to want to actually see how, so the 2 points we're going to use is 0, -2, and 5, 0. We're going to want to find how much we need to move to get from one point to the next. And I always like going from left to right. It just makes it easier for me. So we're going to want to start at the leftmost point, so that would be 0, -2, and find out how many spaces up or down we have to go. So in this case, we have to go 1 space up, and how many spaces to the left or right we have to go. So we have to go, well, the 1 space, make sure you're careful with the scale. The 1 space actually counts as 2 because it's counting by 2s. And then we want to also figure out how much we're going left or right. So in this case, we are going to the right. How many units? We're going 5 units to the right. So slope is always change in y, so up and down, over change in x, left and right. So to go from 0, -2 to 5, 0, we go up 2 and to the right 5. We're going in the positive direction. Up's going positive, right's going positive. So therefore our slope, the change in y over change of x, would just be 2 over 5. So that's how you would find it graphically. But a lot of times we're not going to have a graph, so we also need to make sure we can do this algebraically. So algebraically, find the slope. Very similar first step. We need to have 2 points whose coordinates we know for the slope. So we first want to find 2 points on the line whose coordinates we know. And then we're going to use our slope formula. So then we can use the rate of change formula, which is y2 minus y1 over x2 minus x1, to find the line's rate of change. So I'm going to take our 2 points that we have here. We have 0, -2, and 5, 0. And we need to plug this into y2 minus y1 over x2 minus x1. Now, what does this mean right here? That y with that 2 in the bottom right. That bottom right, when it is called a subscript. So that is telling you this y2 is the y value in your second point, which we're going to say this is our second point. So that would be 0 for this. And this y1 is the y value of the first point. That's what a subscript tells you, the location of that y value. So it's in the first point. So I'm going to label both these points with x1, y1 and x2, y2. That just helps me because now I can just easily plug in where it goes. So the x2 goes in for The 5 goes in for x2, and the 0 goes in for x1. So we have 0 minus, make sure you write 0 minus -2. It's not 0 minus 2, it's 0 minus, and then we plug in -2 in for y1. And then 5 minus 0 is on the bottom. We end up getting the same exact answer, which would be 2 over 5. So you could solve this graphically, you could solve algebraically. You should get the same answer no matter what. Let's go to the next page. So on the next page, we're going to get more in depth into slope. So slope, think about when you see like a slope on a hill or a slope on a mountain, you generally think of going up, but it's also going up over. So slope is just that change in the elevation. So it's going change in y, which is going up or down, change in y, over the change horizontally, which is x. So it's a change in y over change of x. You can also write it change. You can write it as delta, which is that triangle symbol, change in y over change of x. The delta means change. So you always need 2 points to find the rate of change or slope, and we'll talk about speed in a second. So I'm going to choose 0, 2 here, and I'm going to choose 2, 3. I know a lot of people think of it as rise over run also. Rise, you could, that's another way. It's another way slope is stated, rise over run. Think about rise. It's vertical, and so up and down. Run, you run left and right. So that's another way of saying it. So if I look at the graph, how much am I going up? So go to my leftmost point. I'm going up to get to the other point, 1. So I'm going up. 1 would be plus 1 in my change in y. And I'm going right, 1, 2. So I'm going right 2. That's in the positive direction, so that's also positive. So my change in y over change of x, or you can think of it as rise over run, is 1 over 2, which is the slope, which is m. Another way you could find slope is using the rate of change formula, y2 minus y1 over x2 minus x1. That is also the change in y. It's seeing you're subtracting the y's to see how the y is getting different, and same with the change in x's, x2 minus x1. So if I look at my 2 points over here, I'm going to use the same 2 points. This would be x1, y1, and I'm going to say this is x2, y2. So if I were to find the slope algebraically, y2 I said was 3 minus 2. I also said x2 was 2. That would be 1 over 2, which I find a slope of 1 over 2. And you can choose any points on that line that you want. If it's linear, it's all going to have a constant rate of change. So you can choose any 2 points. You can, as long as, if you say 1 point is 0.2, that means, so I said 2, 3 was 0.2. That has x2 and y2. You can't say that's x1 and y2. They have to be together. So this is x1 and y1. And if we were given a linear equation in y equals mx plus b form, what's my slope here? My slope is just m. So that is the variable we use for slope. We use the variable n for slope. M. So I said we're going to get back to speed. We're going to talk about speed. Why is speed a rate of change? So think of speed. Everyone thinks of speed like a car going a certain miles per hour. So if you think of a certain miles per hour, that is just, think about the change in y over change of x. That is just if the y's value is distance, let's say it's miles, and the x value is time, we'll say it's hours, that's a speed, which is a rate of change, was how many miles you're changing per hour. So whenever you see speed, you also want to think rate of change. I want you guys to take 2 to 5 minutes and complete 1, 2, 3, 4, and 5. Pause the video if you haven't. Looking at number 1, we're given 2 points. We want to find the rate of change between those 2 points. So if we only have 2 points, you could find graph paper and graph it. I think the easiest way for this is just to use the slope formula, which is y2 minus y1 over x2 minus x1. And I also like to just label my points too, because it helps me not make a silly mistake. So my first point we'll say is x1, y1, and you could say it's x2, y2 if you want to. I'll say the next one's x2, y2. So when I plug this into the equation, make sure when you substitute in, you're using parentheses. So my y2 is negative 8. My y1 minus negative 1 all over x2 is 12. x1 is 9. So that would be, I keep change on the top. The top would be negative 7 over 3. And we just want to leave that. We leave slope as the improper fraction. Number 2 is nice. Y is solved for. It's in y equals mx plus b form. So my m is 2 over 3. That's what my slope is. So my slope is just 2 over 3 there. Number 3. So I'm going to, you could take 2 points out if you want to. I'm just going to do the y2 minus y1 over x2 minus x1. I'm just going to solve this thinking of rise over run. So I pick 2 points here. I go up 1. So my change in y is 1. And I'm going to the right. So it's positive 1, 2, 3, 4. To the right, 4. So my slope is just 1 over 4. And number 4. So this one's not as easy as number 2, because number 2 already had y solved for. We have to solve for y in this case. So first step, let's get that plus 1 out of there. I'm going to subtract 1 on both sides. We'll have negative 4y equals 7x minus 1. Get the y by itself, divide by negative 4 on both sides. That gives us y equals 7 divided by negative 4, would just be negative 7 over 4. X, negative 1 divided by negative 4, plus 1 over 4. And my slope, I'm in y equals mx plus b form, so my slope is going to be m, which is negative 7 over 4. And the last one, it's a speed question. A car is traveling at a constant speed. It travels 165 miles in 3 hours and 385 miles in 7 hours. Find the car's speed by using both times. So really what this is giving us, it's giving us a point, 2 points. So this would be 3, 165. And this would be 7, 385. And I would just use the slope formula y2 minus y1 over x2 minus x1. So I'm going to switch it up here. I'm going to say this is x2, y2, and I'm going to say this is x1, y1, just to show you guys, doesn't matter which one you say is the first point or second point. So my y2 in this case is 165. So it'll be 165 minus 385 all over 3 minus 7. When I do this, I get negative 220 on the top over negative 4. Now negative divided by negative is going to make it a positive. And we're going to get 55. Now put in a context of the question. The top was miles. The denominator was hours. So that would be 55 miles per hour. So whenever you see speed, always think rate of change, because speed is a rate of change. It's how many miles you're changing per hour, or how much distance you're changing per unit of time. Let's go to the next page. Here I just want you guys to do these 3 questions. So this question, and the bottom question. Take your time. Take 3 to 6 minutes on this. Take your time and pause the video and play again once you're done. So let's take a look at the first one. Which function has a constant rate of change of -3? So I think a good multiple choice game plan is to always try what you think is the easier one first. So I'm going to look at, I think the graph is the easiest one to find for me personally. So I'm going to look at the graph. I'm going to choose 2 points, 2 nice points. There's a point and there's a point. So the slope between these 2 points would be to the right 2. So that's going to be my denominator, 2. And down, so I know it's going to be negative, down 1, 2, 3, 4. So down 4. So it'll be negative 2 over 4, which gives me a slope of negative 2. I need a slope of negative 3. That's not the case. Let's take a look at 4. So I have 2y equals negative 6x plus 10. So I'm going to write that out again. I'm looking at this one. I think, oh, this one's not too bad to do. If I divide by 2 on both sides, I have the y by itself. So y equals negative 3x. 10 divided by 2 is 5. And my slope here is negative 3. That's my answer. It has to be 4. But let's just take a look at the other ones. Look at 1. 1, you're going to have a positive rate of change here because it's going up. So this is actually going to be 3 over 1. And then look at, and we need negative 3, not positive 3. And look at number 2. Number 2, if you find the rate of change between the first 2 points, it actually is negative 3. But it has to have a constant rate of change, so it has to be between every single point. So then you want to check the middle 2 points, and that does not have a constant rate of change of negative 3. That between those second 2 points, the second and the third point, that rate of change is going to be negative 7. So that's why the answer is 4. Let's look at the next one. So this is which hourly interval had the greatest rate of change. So when you look at it here, I'm just going to show you what the interval would be. So hour 0 to hour 1 would be from, look at the hours as an X. So from hour 0 to hour 1 would be this part of the line segment. Then we look at 1 to 2 would be from 1 to 2 would be this part of the segment. 2 to 3, hour 2 to hour 3 would be this part of the segment. And then hour 3 to 4 would be this part of the segment. So if it has the greatest rate of change, that means it's going to be the steepest rate of change. So I want to look at which segment's the steepest, which part of the segment's the steepest. You look at 3 and 4, definitely not 3 and 4. You can check 3 and 4 if you want to, but those are definitely becoming less steep and more flat. I can't tell between the interval of 0 to 1 and 1 to 2, so I'm going to find the slope of those 2 points. So between those 2 points, so this is 0, 0, and then it ends at 1, 2. So let's find the slope between hour 1 and hour 0. So that would be 2 minus 0 over 1 minus 0. So that between 0 and 1, we have a rate of change of 2. And then we'll look from 1 to 2 to 2 to 3.5. That's going to have a rate of change. Oh, that wouldn't be a 0. 0.5 minus 2 over 2 minus 1. That's going to have a rate of change of 1.5. Which one's a greater rate of change? Well, 2 is greater than 1.5. So it would be choice 1. And the last question on here, and before we get to this last question, that other question is a very common question. You never just want to eyeball it unless it's obvious. You can if it's obviously one's much steeper than the rest. But here it's kind of close, so just make sure you check the intervals that are potential answers. And the last question. So we're trying to find the average speed. Whenever it says speed, you should be thinking rate of change in meters per second between 5 and 10 seconds after it was dropped. So that 5 and 10 seconds, that's talking about the x coordinates. So one of them is going to be 5, and the other x coordinate is going to be 10. We just need to find the corresponding y values for each of these. In order to do that, we have to plug 5 and 10 into the equation it's telling us. So that would be y equals 0.8, x has to be 5 in this case, 5 squared. That would be y equals 0.8 times 25. Feel free to put that in your calculator. That's going to be 20. And we'll do the same thing with 10. So y equals 0.8, 10 squared to get the y value when x is 10. That's going to be y equals 0.8 times 100. That's going to be 80. So we have our 2 points. Now we just need to find the rate of change between those 2 points to find the average speed. So that would be 80 minus 20 over 10 minus 5, y2 minus y1 over x2 minus x1. You get 60 over 5, which is 12. Choice 1. That's it. The rest of this is just a lot of practice with rate of change. Highly recommend doing that.